All right, related rates, provided notes. So far we've used the derivative mainly as the slope of a tangent line. Like we've had that drilled in our brain. Slope equals derivative, derivative tells us slope. Remember though that instead of having delta y over delta x, we could do delta s over delta t. Anybody from physics recognize what change in position over change in time is? Without looking ahead? Velocity or speed or rate. Maybe this will help. If we go 300 miles in 6 hours, all right, back to me. We wasted enough time already. If I go 300 miles in 6 hours, you would say my average velocity, average speed, average rate, 50 miles an hour, right? 300 divided by 6. Even better, 300 miles divided by 6 hours is 50 miles per hour. Units become important in here, just like they do in physics. Like a lot of times in physics, you can kind of figure out how to get the answer based on the units. If the question says how many miles per hour did you go, well, miles per hour, divide miles per hour. If we put this through the limiting process, so if we take a limit, we will have ds dt, which represents instantaneous rate of change. And that's what we're going to talk about next. So instantaneous rate of change is like what the speedometer tells you. Average rate of change is, well, I went 300 miles in 6 hours, that's 50 miles an hour. My speedometer is reading 53 miles per hour. That would be my ds dt. That would be my instantaneous rate of change. But first we're going to get comfortable with the notation, and that's what we're going to do today. Notice that to get an instantaneous rate of change, we are often taking a derivative with respect to time. So d dt rather than d dx. Let's try to translate a few sentences using proper calculus notation. And so it's just like understanding, and there's nothing to calculate, just to understand what they're saying. The area of a circle is increasing at a rate of 6 square inches per minute. So something is 6 inches squared per minute. Let's start with the easy part of this problem. Area of a circle is increasing at a rate. Rate means derivative. Rate means derivative. Well, the derivative of area. In fact, rate means derivative with respect to time. So we'll have something dt. That's what rate means. And if it's the area, it would be dA dt. The area per time, inches squared per minute. The units still have to work. Area per time, inches squared per minute. The volume of a cone is decreasing, well, that's different than increasing, at a rate of 2 cubic feet per second. The easy part first, 2 cubic feet per second. Well, what is 2 cubic feet per second? What goes on the left-hand side of this statement? Okay, you could put the negative over there. Because it's decreasing, most of us will put the negative on the negative too. It's going down. So good on the negative, and you said dV dt. dV dt is negative 2 feet per second. Why don't you try the next three? You're just translating English to calculus. Population of Pflugerville. This worksheet came from someone who teaches at Pflugerville. It's growing at a rate of 3 people per day, so dP dt, 3 people per day. Height of a tree, increasing at a rate of half a foot per year, so dH dt, half a foot per year. Water level in my fish tank is decreasing, so careful with the minus sign, 2 inches per hour. The only thing tricky about number 5 is like, what variable do you use? Do you use L for level or H for height? It doesn't matter. It doesn't specify. Either one would be fine. All right, 6 through 10. If I give you the following, try to write a sentence that correctly describes the relationship. So it's the same thing, it's just going backwards. So number 6, dc dt is 2 inches per day. So what would be c that is in inches? What could c stand for that we would measure in inches? Circumference. I suppose it could be something else, but circumference seems to make the most sense to me. The circumference is increasing at a rate, you need to have the word rate in there, that's what tells us it's a derivative, of, and the rest is the same, 2 inches per day. Alright, I need an S. I need a variable that starts with S that we could measure in yards squared. Oh, the side of a barn or something would be area? The area of a side, that's fine, that works for me, is increasing at a rate of 5 yards squared per minute. Eight is maybe a little easier. What starts with A that has a unit of feet squared? Area. So that one's a little easier. The area, although what's different about number 8? The area is decreasing at a rate of 4 feet squared per second. Be careful, don't say it's decreasing with a negative 4, because then you've got like the two negatives make a positive thing. So be careful about that. It's decreasing at a rate of 4, which makes it negative. I think we'll need to stop about there. So finish 9 and 10, and then finish that implicit differentiation worksheet. And the differentiation worksheet is posted in Schoology. All of the implicit differentiation worksheets. For related rates, you can stop at number 10. We'll pick up the notes on Friday. So that's just a little bit of an introduction to see some different units involved. And then on Friday, we'll do some more derivatives with it. So practice the implicit, maybe look over the related rate stuff, and we'll be ready to go on Friday.